Welcome to the Explainer. Today we are cracking the case on a tool that you've probably seen a bunch, the digital multimeter. Now, I know it can look a little intimidating with all those dials and symbols, but trust me, by the end of this, you're going to see this thing as your own personal electrical detective, ready to solve all sorts of mysteries. You know the situation, right? The TV remote just gives up. So you go to that one drawer, the one filled with maybe good batteries. But is the battery you grabbed actually fresh, or is it totally drained? It's a simple question, but really, without the right tool, it's just a complete guessing game. Or hey, what about this one? A lamp that just won't turn on. You've already checked the bulb, you know the outlet works, but what if the problem is completely invisible? You know, a tiny hidden break somewhere inside the cord itself. Well, these are the exact kinds of mysteries our little detective here is built to solve. And here it is. The digital multimeter. The easiest way to think about it is like a pair of glasses that lets you see electricity. It measures those invisible forces flowing through all the wires and components around us, and it gives you cold, hard facts to work with. Basically, it takes all the guesswork out of the equation. Okay, so to solve any case, a detective needs to know their kit, right? So let's get acquainted with the essential parts of our multimeter. And you know what? There are really only 4 key areas you need to know to get started. It's that simple. First up, you've got the LCD screen. Pretty straightforward. That's where all your readings, your clues are going to show up. Then there's the big dial in the middle, the rotary switch. That's what you'll use to choose which mystery you're trying to solve. Down at the bottom, you have the probe jacks, which is just where you plug in your test leads. And finally, the probes themselves. Think of these as your hands, letting you safely touch and test different parts of a circuit. All right, let's solve our first case. The mystery of that questionable battery. This is, by far, the most common job for a multimeter, and it all comes down to measuring something called voltage, which is kind of like electrical pressure. First things first, the setup. The black probe pretty much always goes into the jack labeled COM. That just stands for common or ground. Then the red probe goes into the jack that has a V for volts. Easy enough. Next, you turn that big dial to the symbol for DC voltage. That's the V with the straight, solid line next to it. That line tells you we're measuring direct current, which is the kind you'll find in batteries. And now for the test itself. You just touch the red probe to the positive side of the battery, the little plus sign, and the black probe to the negative side. Now look at the screen. For a normal A or AAA battery, you're hoping to see a number right around 1.5 volts. For one of those rectangular 9 volts, well, you're looking for 9 volts. And hey, here's a little pro tip. If you see a minus sign next to your number, don't sweat it. It just means your probes are reversed. The reading is still totally accurate. So this is a really crucial point. You have to know what kind of voltage you're measuring. DC or direct current flows in just one direction, kind of like water flowing down a river. That's what you get from batteries and most of your personal electronics. Then there's AC, or alternating current, which rapidly switches direction back and forth. That's the powerful stuff that comes out of your wall outlets, and your multimeter has a different setting for each. Now, you can check a wall outlet, and you do that by setting the dial to AC voltage. That's the V with the little wavy line next to it. But, and this is a big but, I have to say this, household electricity is incredibly powerful and can be dangerous, so you have to be extremely cautious anytime you're testing AC voltage. All right, detective, moving on to case number 2, that faulty lamp cord. We think the outlet has power, but is the path for the electricity actually connected? For this, we're going to use a super useful test called continuity. The setup for this is so simple. The probes, they stay in the exact same jacks as before. You don't have to move them. All you do is turn the dial to the continuity setting. You're looking for a symbol that kind of looks like a little speaker or maybe some sound waves. This tells the multimeter to check for a complete unbroken path. And the test itself is, honestly, it's brilliantly simple. First, make sure the device you're testing is completely unplugged. Then, you just touch one probe to each end of the wire. If the path is good, the multimeter will let out a really satisfying beep. That sound is your answer. It means electricity has a clear path to flow through. If you just hear silence, well, you found your culprit. You've got a broken wire. Case closed. Now, a test that's very closely related to continuity is called resistance. It's measured in ohms, that's the Greek omega symbol. The setting tells you how much something is fighting the flow of electricity. We won't get deep into it today, but I have to tell you the #1 most important safety rule for this test. The circuit must be completely, totally unpowered. No batteries, not plugged in, power off, period. Okay, So you've just learned the two most common tests that you'll probably ever use. But before we wrap this up, let's go over a few crucial safety rules and take a quick peek at a more advanced function. After all, a good detective is a safe detective. Listen very closely, because I absolutely cannot stress this enough. Never, ever, ever try to measure current, which is different from voltage, by sticking the probes into a wall outlet. It will create a massive short circuit, it'll probably blow a fuse inside your meter, and it is just extremely dangerous. Please, don't do it. So, measuring current, or amps, is definitely a more advanced technique. See, unlike voltage, which you measure across something, current has to be measured in series. What that means is you have to physically break the circuit open and then insert the multimeter into it so that all the electricity actually flows through the meter. It's how you'd figure out exactly how much power a device is using, but it's a skill for when you're a bit more experienced. So let's just recap everything with a super handy cheat sheet. You've got DC voltage with a straight line, that's for batteries. AC voltage with a wavy line, that's for wall outlets. The little speaker icon gives you that awesome continuity beat for checking wires and fuses. And the omega symbol is for resistance. And remember, always with the power off. Honestly, this little chart covers about 90% of what most people will ever need. And finally, you've got to take care of your detective's kit. It's simple stuff. Always turn it to off when you're done, that'll save the battery, and never try to measure voltage if you accidentally left the dial on the resistance or continuity setting. It can actually damage the meter. And just like any good tool, try to keep it clean, keep it dry, and pop a new battery in when it asks for one. So there you have it, the digital multimeter, completely demystified. See, it's not so scary after all, is it? It's an incredibly powerful tool for getting real answers about all the electronics that are all around you. So now that you know the basics, the only real question left is, what's the first mystery you're going to solve?